So another question, again, no, this is an interesting question from Raghavan. So he's asking, how do you identify which clones are good and which ones are bad?
Yeah,
So he
that
says that I
yeah.
guess good ones are the ones that can be lived with. So how do you identify? So essentially, this is about quality of the code
Yeah,
clones.
so yeah, that is a lot of things we have been working on recently for last few years, ranking of clones and finding out which one is good clone, bad clone, which one is which one we can live with the system, which one we must have to take care of, which one we if we cannot really remove it, can we really track them over the time? So this is we have been doing over the last few years, and this is a very good and thoughtful question, and our a lot of our research is actually based on this question. So thank you, Raghavan. And so like first of all, we look at we look at the evolution history for a clone, for example, or for a set of clones for a system, and then we look at whether they are related with, like, let's say, bugs in the system over the evolution, whether the bugs was fixed, whether if I make a change in this fragment, how many other fragments are being changed over the evolution, if I whether this fragment is kind of having coupling with a lot of other fragments, whether being clone or non-clone. So if a code fragment, for example, in particular a clone fragment, is kind of linked with a lot of other fragments, that means that this clone is kind of dangerous, because if you are making a change, then maybe you need to make a lot of other changes. So this is kind of a potential clone that you need to take care of. Or if you have a clone and that had a bugs, right? So you exactly know that you have to kind of remove this clone from the system, or you have to take care of it, or you have to kind of make the changes properly so that bug could be removed. Or like, let's say you have two fragments of code, they are changing over time, but then maybe changes are not being consistent, and because of that inconsistency, maybe they are getting introduced bugs or other kind of inconsistency in the system. So those are also kind of problematic. And good clone, for example, is kind of the clones are in there, they have no dependency with other other things, not other files, no other fragments, they are good, they are well tested, there is nothing happened with them over for bugs over the evolution, they were never changed, so they kind of live as they are. So if somebody is changing a lot over time, and if they are clones, that means that if you are changing one of them, you have to always change the other fragments too. So this is kind of a dangerous clone, another example of dangerous clone. So we look at the most of the time we look at the evolution history, we look at their relationship with bugs, we look at their relationship with coupling, we look at their relationship with like we use coupling is one of the things, like we use association rules for that one to find out mostly, and also we use like let's say if you are changing, even not with clone, if that fragment I'm calling a fragment, I have a method, and in that method I have a parameter, and that is calling another method. So if I have those kind of lot of those caller call relationship for a fragment, and that fragment is a code clone, that is also kind of a dangerous kind of clone, and it is better to take care of them, or to remove them, or if we cannot remove, we have to at least be aware of it. Okay, I have these two fragments clone, and there are kind of a relationship with other fragments. So if I am going to make changes, I have to make sure that I am going to change the other two, or there should be a tool that can notify you, okay guys, you made these changes, you have to make changes to other too. So those kind of a study we have been actually doing a lot, and including providing support in the IDE. So that is a very good question, Raghavan. Yeah.
Right. Yeah. Thank you, Chanchal. There are a couple of more questions. I think what we will do is we'll go to the other talks. If there are questions from other talks, if there is time, we'll come back to these questions.
Sure. Yeah.
So does any of the participants have questions for Ishan on lambda expressions? You can raise your hand. You can unmute yourself and ask question or your comment.
So I have a question for him actually.
Yeah, sure, sure. Please go ahead, Chanchal.
So my question was, looking at this, I think this is a very good study, and looking at that, I was just wondering if somebody really just wants to write lambda expressions. then what percentage of code, let's say the systems that you studied, what percentage of code could be written using lambda expression? How my question was, can we really extensively use lambda expressions in Python programs?
Okay, thank you, sir, for the question. Yes, we can use, but that to depend on the context of what you're actually trying to do with a respective function. So, but that being
Maybe you can turn off your video, Ishan, if the bandwidth is low. We lost you. Ishan? Okay, it looks like we lost Ishan probably. Ishan, maybe you can type the answer if it is okay. Or what we can do is we can go to the next speaker and come back when Ishan is fine. When he gets the bandwidth. How about that?
Yeah, sure.
Yeah, so if you have any questions for Naveen on code comprehension and cognitive load, please go ahead and ask. Any questions for Naveen on code comprehension and cognitive load? So Naveen, I have a question actually. So I was just wondering, like, yes, cognitive load, especially given the kind of oh, Ishan is back. Ishan, what we are just doing is we are going ahead with Naveen now. We'll come back to your question if it is okay.
yeah,
Right?
fine.
Okay, so yeah, so Naveen, so what I was wondering is like there can be different kinds of tasks, like even in code reading and debugging, right? So did you kind of classify different kinds of tasks and such as debugging tasks and what is the cognitive load on this kind of tasks?
Hi, Sridhar, can you hear me?
Yeah, I can hear you.
Okay.
Yes, we can hear you.
Yeah, so that's the whole purpose, or rather the conclusion that we draw out of this whole study, Sridhar. So what we found out was that developers use different techniques for different types of tasks. Like you mentioned, for debugging they use a completely different approach, and for general reading, right? So if you are given with a new code, then you would basically start reading the code. Then it's a completely different approach of reading code. So it's a very interesting area and very diverse if you look at it, like considering the kind of number of tasks a software engineer does given the code.
Right. Any questions for Naveen or comments? Okay, so I have one more comment, Naveen. So what I was wondering is, so you said about this code comprehension, right? But developers also spend time in reading other kinds of artifacts, such as be it testing, unit test cases or code reviews and so on. So I'm wondering if there is some work on comprehending these kind of activities, tasks, or what do you think in that direction?
Yeah, there are multiple artifacts, definitely. But again, given the fact that code is the source of truth, and if you look at the studies that have been conducted by Murphy and everyone else, predominantly almost like 80 to 90% of the time or effort the developers spend in reading code. So it was kind of prudent for me to look at that first as compared to other artifacts.
Okay, yeah. Thank you, Naveen. So probably
I have
we'll
one question.
Oh, you have? Okay, sorry. Yeah, Ishan, go ahead.
Yeah, Ishan.
Yeah, with adding to this context, how we can leverage this thing in GitHub projects. Like many times we have to clone a certain.
True. See, what happens is that is exactly the way the whole study is extending towards. If you today see that a lot of projects are cloned, a lot of projects are extended. And when you, for instance, imagine that you found a project which you wanted to extend and then add your own capabilities. So now you clone the project, and then it's up to you to understand the whole code, and then you would end up reading the code. So now how do we make it, that entire experience of reading code, much simpler, make the reduce the cognitive load in terms of reading the code? That is the whole objective here. And as you mentioned, this is becoming more and more important given the fact that a lot of projects are on GitHub, and it's very easy for us to clone the project and then extend it ourselves. Or in fact, you found a bug in a particular project and then you fixed the bug. You wanted to fix the bug, but now to fix the bug, you will have to go understand what exactly is the code and then contribute it back, right? So that's again the scenario where code reading also comes into picture at a large scale.
Right. Thank you, Naveen. So, let's. We have a question for Nitin from Raghu. So, what is the extent of implication of the actual use case description itself? I mean, is it templatized natural language or is it free form natural language? So, Nitin, could you answer this?
Yes. So, am I audible?
Yes, you are audible. Yes.
Okay. Thank you for the question, Raghu sir. Yeah, I probably suspected that given the examples I showed in the video, this kind of a question might come. So the target is actually like normal natural language that is written in use cases. But it was just these examples which I just showed, which probably look simple. But in the spectrum of the simple things that I showed, till the complex natural language use cases that are written, the performance of the thing also varies. So it's like for simple things it would work, of course, quite well. But as we move into the complex, like very intricately written use cases in English, the approach would falter. Because as you see the kind of steps that are involved, like the actor extraction or the message creation, so all those have their own error probabilities. So it's a pipeline basically. So all these error probabilities kind of accumulate, and then at the end, the end-to-end thing probably may go wrong on complex questions. So that's the answer.
Yeah. So, any other questions to Nitin from the audience? Yeah, Raghu, you've raised your hand. You can.
Just a continuation in a way, continuation, because see, if you look at it, we are still at the problem domain from the perspective of moving from use cases to, let's say, system level sequence diagrams, if I can call that, right? But you're calling them message sequence charts. You know, to me, the message sequence charts are moving to the solution domain, right? So you're actually moving from a problem domain to a solution domain. And automating movement of a problem to a solution domain is rather not a very simple task, because there is no one-to-one mapping, and it's purely an M by N relationship, right? So one thing here might mean many there, many things here might mean one thing there. So how are you actually handling such a problem?
So I would like to, rephrase the question. I mean, some part of the question a bit. So it's like our focus is primarily more towards understanding of the problem rather than going into the solution domain. So that is like my perspective to the thing. So in during like the whole aim is to understand this text written. And then once we come to this, so as you rightly pointed out, this message sequence chart is actually the, I would say, the parent notation for sequence diagrams. So that's correctly pointed out. So I think the goal that we started with was of analyzing these use cases primarily. And then if there are some I should say gaps or certain things that the MSc can point us to, so that was primarily the focus. I think I answered a different question.
Yeah, thank you.
Yeah, thanks, Nitin. Nitin, one quick comment, if you can be sharp. So I was just asking, like, how do you deal if a use case is not complete or there is a lot of noise in the use case, right? So is that an assumption that you're making for your work?
Yeah, so like pointing back to my first answer, that if there is noise or the text written is incorrect, then basically we are relying on the NLP infrastructure that exists. So the OpenAI tools or the WordNet. And if they go wrong because of the noise, then obviously we are not handling that in the approach. But that's a very good comment. I mean, we should look at, making it more robust to the noise. So yeah.
Right. Okay. Yeah. Thank you. So, Ishan, I hope you're back with audio, at least if not video. Are you there?
Yes, sir,
Yeah.
I'm here.
Probably you can answer, Chanchal's question.
Yeah, sure. Okay. Sorry for the disturbance. So, coming back to question whether it is useful, whether we can use lambda expression extensively in a project. Answering To answer that question, that depends on the context of the project as well as developer how he's segregating the different modules and how he's writing. But generally, lambda expressions are only dealt with smaller codes. So if the developer is actually using 1122 line statements in a function, that can be converted to lambda expression as well. So instead of writing a full-fledged function in which you have to write separately different call function or different definition, we can rely on single line of lambda expression.
Yeah, I know. I mean, this involves two different things. Like, do we really need it? And second is how difficult it is to write it. How easy it is for the developers to write it. So that's what because it is very interesting. And I'm asking this question because like in my MSc thesis, I was doing in Germany, and I kind of transform functional languages, let's say Erlang to PyCalculus. Okay. And also we did a lot of things with Haskell and in their semantics, and we did a lot of those lambda. And so you can, like, even PyCalculus, right? It's very few syntax, and you use make a lot of those things, right? Lambda calculus, kind of similar. So it was very good, but sometimes maybe I don't know whether the normal developers, whether they are able to use it properly or whether the context actually allows it to use lambda expressions. Because if we can really do, there are a lot of benefits. That's sort of my question. Like even for clone detection, I was going to ask you my second question, whether actually how much of, whether there is any tool that can, let's say, transform Python code. Let's say you have traditional Python code and you have a tool and that can transform that Python code to Python code with lambda expressions whenever possible, for example. And whether we get extra benefits in terms of performance, in terms of quality, in terms of readability, like comprehension. So those are the things, the question, or maybe a lot of future directions actually involved with it.
Actually, sir, whatever the points that you make actually are in sync with our broader objective with respect to this lambda expression. So the broader objective is to help new developers to tell that apart from normal functions, you have other alternative as well, and these alternatives can be used in different aspect, and these are some of the cases, and you can refer these cases to sharpen your code. That is a broader objective. So yes, we took your points and we are actually working on this.
Okay. Yeah, I mean, it's not only about, I think it's, if you look at more on in terms of verification purpose or in terms of program comprehension purpose, in terms of like even for, if you have lambda expressions, maybe, you do not need, they can understand the program better. They can make changes easily, like from one part to another one, because lambda expressions are not many, right? They are kind of same type, but you have to understand it properly. So, so maybe if you look at not only for alternative options to the programmers, but maybe you can convince them, or you can find out some other benefits in terms of software quality attributes.
Exactly.
That would make it better.
Sorry, Chanchal, I think that's a very valid point, because like if I use these lambda expressions, does it help? How does it help? So how do you convince a programmer that yes, it actually helps in certain aspects? Maybe how does it improve something? Does it improve the quality or certain aspects, right? So I think that's a good suggestion. I think Ishan, probably you should try and see if you can do that. So let's take the
Sure,
comment from Naveen. Naveen, yeah, please go ahead.
Yeah, thanks, Sridhar. Basically, again, I think Chanchal basically was kind of brought this point of comprehension. Rather than a question, it is more of a comment. Because I'm looking at this from the point of view of my work. I mean, when you say we are doing a functional style, or rather even lambda expressions, we are essentially like reducing the number of lines of code. I look at it that way.
yes.
And
Yes.
when you say I reduce the number of lines of code, I also start losing out the queues that a developer would use.
Right.
So
Okay, yeah, true.
I'm looking at it from that perspective in terms of
Right.
how again the code coverage, or rather the code comprehension, looking at from the point of view of number of queues that were lost
Right.
for a developer, that could probably lead to interesting observations as well.
Right.
Yes, sir.
I
That's a
think
very good
we
point.
have a question from Rahul. Rahul.
Hi. Yeah, hi. So this question is to Chanchal. So Chanchal, hi, this is Rahul here. Am I
Hi, Rahul,
audible?
how are you? Thank you. Yeah.
Yes,
I'm
Rahul,
Yeah.
please go ahead.
okay. So my question is regarding clone detection, and typically, it happens at a function level, right? I mean, when the function boundaries match with clone boundaries. But when clones are kind of embedded within code snippets, they can be small, they can be large. So they will be hard to detect, right? So what is the state of the art in this kind of a situation, where we need to find clones that are embedded inside, larger, snippets, larger code?
Yeah. Yeah. Thanks. Good question, Rahul. Actually, many of the tools, they work both, they look for also code snippets inside the functions. Like, let's say one of the oldest tool is called CC Finder. They look at the token similarity, and they do not care about whatever the similarity is. So they consider the whole program as a sequence of tokens, and then they find out, okay, what sequence is similar between in this program. What are the set of sequences similar? So they really do not care about even function boundaries. That is the problem sometimes, but they can give you the longest sequence that is similar.
I see.
So doesn't matter.
Let me kind of refine my question. So my question was mostly from type 2 and above clones. Sorry to interrupt.
Yeah. No worries. Yeah. So it's the same thing. Like there are we have like source RCC. We talked about method, because when you actually deal with thousands of projects, maybe going for a larger size is better, and maybe going for function level is kind of easier a little bit, because you are right away getting to compare different functions. But for example, for say, and even for source RCC, we can do in blocks, and also for NiCad, for example, we can do blocks. So we can take all those different blocks, let's say beginning bracket and end bracket, and we can take all those different blocks, thousands of blocks, and we can put into the system, and we can compare. So we can still, and then we can recommend the longest one, let's say. So we can recommend the smaller one, and if the outer one is also similar, then we can capture the outer one, and then we ignore the smaller one, because we already know the bigger one is already similar. So we can go from a smaller one to as big as, even to the file level. So that it is there. So those are the thing. Some of the tools, they can even for like tree-based tools, they can also consider kind of node, right? So they can also look at, and they convert the nodes to the tokens. But let's say after that they're using suffix tree, some of the comparison algorithms. So they can find out sequence of similar nodes, sequence of similar tokens, sequence of similar text, sequence of lines. So they can actually work on both granularities, like both either on fragments and on method. Yeah.
So thanks Rahul and Chanchal. So
thanks Chanchal.
There are a couple of questions from the chat room. Chanchal, if you can answer through the chat room itself from Shavik and Arpit, that will be great.
I cannot see it, because can you read it for me, please?
Oh, okay. So so maybe quick 30-second answer. Is it possible to detect clones across languages? that is a clone of C program in Java? This is from Shavik.
Yeah, right now actually we have a recent tool that works on multiple like across languages, and we published in ASE 2019, so last year.
Okay.
And that where we do not compare kind of source code, because it is different languages. We kind of look for the APIs, and then we capture the API uses, and then we go to the API documentation, and then we compare using deep learning methods the documentation. So that means that for us, the language doesn't matter, because we are looking at the different kinds of, like say, write line, right, or write or print. So
Right.
different languages use different thing.
Yeah, sorry to cut off. A related final question is, so if there is no concrete definition of code cloning, so how do you generate ground truth for type 2, type 3, and type 4 clones? This is from Arpit. So probably you can quickly say, like, in 20-30 seconds.
Yeah, so we have some, although we do not have a right definition, but for type 1 and type 2, we have a concrete kind of definition, because type 1 is similar syntax, only formatting difference is allowed. For type 2, you can allow variable names to be changed or data types to be changed, but the tree structure, let's say if you convert them into a tree, AST, then the tree should be the same. The only problem with type 3, because we do not know how much modifications, how much additions we can allow, and that's what the problem. So for that one, like for when we made the big clone bench, we kind of, let's say we are looking for an implementation for, let's say, hashing, like MD5 hashing. So we think of what are the different implementations of MD5 hashing, and then we look for, okay, what are the terms are dominant in those implementations, and then we use those terms to use grep or some other searching technology to look for in these 25,000 Java projects, and then we manually actually kind of look in all those fragments with a lot of developers, and to find out whether those functions are actually implementing MD5 hashing.
Right.
And then if they are really implementing, they are talking about the implementation of MD5 hashing, then we say that, okay, these are the fragments that could be cloned, and that could be the clone for implementing MD5 hashing. So we kind of looked at it, and not only by even one developer, we looked at multiple developers. They're looking for those results.
Yes, I think thanks. I think so I would like to thank all the speakers, all the participants for an interesting session, for the entire good discussion as well. So thank you everyone. Thanks a lot. So please be tuned. We will join in about 4-5 minutes. So sorry we are a bit late because of the disruption that had. Thank you everyone. Thanks for joining the session.
Thank you.
So interesting.